Hi everyone. In this video, we will work on number 15.5 from section 5.2. The integrand will be x cubic times sine x squared. So far, we have learned two advanced techniques, U substitution and integration by part. First of all, this structure will motivate us to consider integration by parts formula. And here I also include the integration by parts formula. UdV equal to UV minus V du, which is here. Okay. And the key point is to choose U and V such that the UdV will equal to the integrand, including the dx term. All right. Now, the first step is to start from the choice of U. In this particular case, we will guess x squared. Once we choose x squared, the next step is to compute dv. This could be solved from this equality. All right. So once we figure out the u and the dv, we could simultaneously compute the du and the v. Actually, du is more straightforward because this involves the derivative step. Just don't forget that to add the dx term here. Now, from dv to v, this requires another integration. And we could also apply the u substitution technique here. We set u to be x squared, and we could figure out the v is essentially -1/2 cosine x squared. Notice that the notation u we use here is actually different from the u we use for the u. I mean, I think in this case that is actually the same, but just keep in mind, these two u are used in two different processes. All right, so make sure do not confuse with these terminologies. Okay. All right, now within this table, we figure out u, v, du, dv, and satisfy the requirement here. Now it's time to apply the formula. The original problem can be written as this u dv integral by integration by parts formula. That will be uv minus v du, and then we plug in the choice of uv and the du terms, right? Now it's time to simplify this term, right? And it will become this. Okay, notice that this term is supposed to be an easy one, but however, it seems that we could not figure out the antiderivative directly. However, if we compare this to the original problem where the integrand involves x cubic, the new term here is only involves power 1 of x. All right. So in this sense, we could consider this as an easy term. Indeed, we could apply another u substitution step to figure out the antiderivative. All right, so I will suggest you to pause the video to work on this. Finally, we could write down the answer like this one. Okay. Now I want to make a quick remark here. For some questions, only applying u substitution and the integration by parts may not be enough. Sometimes we will need to combine this method and make sure we apply this technique in a certain order to make it work. Okay, so that's all for these questions.